Welcome to part 1 of GGplot series. Today we're learning the power of geoms, the basic elements that turn boring tables into exciting graphs. Why should you trust me? My name is Bogdan Popescu and I'm an assistant professor at John Cabot University of Rome. I've been teaching generations of graduate and undergraduate students the power of statistics and data visualizations. So let's dig right in. Everyone. So today we're covering data visualization with GGplot2. So at the end of this lecture, you'll be able to understand how grammar of graphics works. We're going to learn how to use the ggplot library in R. We're also going to learn, we're going to focus mostly on how to use the right geom, the right geometry, but the right type of data. We're going to learn what is the right type of data in order to create points, bars, lines, box plots, density plots, and even maps. So it's important to think about what the purpose of visuals is. Of course, in a first instance, you could see something like this, a table that shows, for example, how life expectancy varies across different countries. It's a neat table, but clearly a much better version of this would be something that looks like this, this is what is called a bar plot. So you see on the x-axis what the mean life expectancy for these countries is, and then on the y-axis you see all these different countries. So clearly the bar plot is an alternative, superior version to the same data. So it's important to note the visuals are powerful because they reveal patterns. They show things that are not otherwise visible in tables. They also help us explain results clearly. They also more persuasive. It's clearly that the bar plots are doing a much better job at showing what the top 5 countries are when it comes to life expectancy. So ggplot is the main package, the main library in R, allows us to produce good visuals. So in order to use it, we of course have to have the R programming language and RStudio, which is the interface that allows us to operate with R in a more user-friendly manner. And of course, the library that we need to use is GGplot2. So when it comes to graphics, we can think of plots in ggplots as a set of layers. At the very bottom, you have data, then you have geometries, aesthetics, then you can start adding optional layers such as facets, coordinates, annotations, and themes. This is not necessarily a comprehensive list, but these are, I would say, the most important layers that are useful when producing research. At the most basic level, and this is mostly what half of this presentation is all about, we can have data, geometries, and aesthetics. Additional layers include the ones that I mentioned earlier: facet, coordinates, annotations, and themes. All of these can be added using the plus sign in ggplot, which is why these elements could be thought of as layers in ggplot. Okay, but before we even start thinking about using ggplot, it is important to have tidy data. So it's important that each variable is a column, that each observation has its own row. This is what in the second graph. And then each value has its own cell, as depicted in the third panel of this figure. Okay, simple geoms. This is really the essential of data visualization, the essence of data visualization. So geoms are essentially shapes that the data takes in your graph. Examples, you can think of points when you're trying to make a scatter plot. You can think of lines, you can think of bars when you're trying to create a bar chart, similar to the one that we saw earlier, that shows life expectancy across countries. Or you can also produce lines that are helpful to produce a line graph. So here's, for example, what these things look like. This is an example of a Geom Point. This is an example of a Geom column. This is an example of a Geom Bar. Obviously, visually, they look exactly the same, but I'm going to show you in a few slides what the main difference is. This is an example of Geom Text. As you can guess, this is all about adding text geographs. This is a Geom Line. So these, I would say, are the most simple geoms that are easy to produce in GGplot. So once again, Geom Point really is about showing relationships between two variables. Geom Column is about showing things like totals, percent per category, and these are ordered bars. In this particular context, when it comes to using Geom Column, you have to supply both X and Y. When it comes to Geom Bar, this is something that counts the observations in each category. So here, you no longer need to supply X, you no longer need to supply Y, it's enough to have X. Geom Text is really about labeling points or labeling columns or annotate, whereas finally Geom Line is about mapping relationships between two variables. Okay, so let us take them one by one to see how they work. So let's apply these concepts to specific situations. So let's imagine that we have a data set about 9 countries that shows their level of democracy measured from -10 to 10, where -10 represents the least democratic and 10 represents the most democratic. And we also have GDP per capita in thousands of dollars. So this is what our data would look like. We have a data frame, EG1, that has 2 columns, democracy and GDP. All of these countries have these values. So these are the democracy scores, and these are the GDP per capita scores. Remember that these are in thousands of dollars. So this is, for example, what our data set would look like. Once again, you have a column, democracy, that shows the level of democracy in these 9 countries. And then you also have GDP, which shows gross domestic product across these countries. This is, for example, what this graph would look like. So before we get into the code, let us analyze this graph. On the x-axis, so this is the horizontal axis, we have the level of democracy, once again, between -10 to 10. So points like this would show would be a country with low levels of democracy, and a point here on the right would be a country with a high level of democracy. On the y-axis, we have GDP per capita. This country here, for example, has a low GDP per capita. This country here has a high GDP per capita. So this is essentially the data set in a scatter plot. So let us now look at the code. Notice that we're using GGplot. So this is after we loaded the GGplot2 library. One important thing to note here, this is not GGplot2, although the library is called GGplot. The way we call it when we actually use it is just GGplot. Then we have to tell GGplot what is the main data set that we're using. And finally, we map the X and the Y. So in our case, the X is the level of democracy, and the Y is the GDP. Finally, to indicate that we want points, we have to add the plus sign here, and then to add Geom Point. So this is a good example of when we can use Geom points to show the relationship between 2 variables, in this case, democracy and GDP. So how do we interpret this graph? Each dot represents one country's democracy score, and then GDP per capita. So these dots aligned in this manner suggest that more democratic countries tend to have higher GDP per capita. Okay, let us move on to Geom Col. So let us look at this new example. Let's imagine that we have a survey where we record the level of education for each respondent. So we want to measure, for example, we want to display how many respondents have different levels of education. So this is a new data frame, EG2, and we only have one single variable this time. So we have primary, high school, college. So this would be 5. We have 9 respondents. So our data would look something like this. Notice once again that we have one single column. We would first like to count. So how how many high school, how many primary, so how many respondents with just primary school education we have. So we use the count function from the dplyr package. Notice that I'm loading it here. So we transform EG2 into EG2 transformed. So this is going to give us something that looks like this. So we now have two variables. We have, we have education and we have N. As you might guess, this N variable is essentially counting how many times we encounter college, how many times we encounter high school, and how many times we encounter primary. So we have 4 people that have a college level education, 3 people that have a high school level of education, and 2 people that have primary school education. So finally, we can plot these respondents like this. So notice that we have 4 people with college level of education. We have 3 people with high school level of education. And then we have 2 people who have primary school education. This is how we produce this graph. So we're utilizing the EG2 transformed. Remember that this is the new data set, the new data frame that we created when we counted the respondents. And then we use the X. We say that we want to plot education. So remember, X is really how many we have for primary school. Sorry, X is like the labels. Primary school, high school, and college. And then N is the thing that tells us how many times we encounter college, high school, or primary school. And then to tell ggplot the kind of graph we want, we add Geom Col. So this is what Geom Col is. Okay, the same graph can be obtained if we use Geom Bar. So notice here that we have the same problem, so the same respondents. This is how we can obtain the same bar, maybe more in a more simple fashion. So instead of having EG2 transformed, we're using the original data, EG2, and notice how now we simply add the X. Remember that when we're using Geom Bar, Y is not necessary. So we simply tell ggplot that we're using education for X, and then we add Geom Bar. So just to look at them comparatively, remember that for Geom Col, we used EG2 transformed, and we needed to add both the X and the Y. And then for EG2, we simply provided the X. So notice that the result is very similar, but in the context of Geom column, we had to have this intermediary step. But overall, as you can tell, the graph is very similar, or the result is the same. Okay, let us move on to Geom Text, and let us use the same example. So this is what Geom Text does. Of course, this is a very simple way to illustrate its utility. Geom Text, it's all about adding text to a graph. So here, I just added the level of education, the label, clearly unnecessary because we already have it on the x-axis. But I decided to simply go with this simple example rather than create a more complicated new example just for educational purposes. Here, I decided to go with Geom Col. So I have the EG2 transformed dataset. Remember, this is the dataset that counts how many people with high school level of education, how many people with primary school education, and how many people with college education we have. We have the Geom Col exactly like before. What is different now is this part, Geom Text. Within Geom Text, we have AES, so which stands for aesthetic. We have the label, so we want to add these levels of education. And then we have to indicate where we want this text to be placed. So here, remember that the N is really how many observations we have per category. So if we say N plus 2, N divided by 2, this would divide and add these labels here near the columns. Okay, so this is how we use Geom Text. We can also use Geom Text in the point example. Remember that we had this example in which we had 9 countries that have both the level of democracy and GDP per capita. So notice now that I added a new column called country, right? So we have countries like Korea, Saudi Arabia, Zimbabwe. So I'm using exactly the same data that we had before. Now I'm just adding labels to these countries. So our data would look something like this, right? So note that I'm only including these 5 observations in order to be able to fit those observations of this table into this slide. So we notice that we have 3 variables now instead of 2. So we have democracy, we have GDP, and we have country. So this is what this looks like now. So as before, we still have the level of democracy on the x-axis. We still have GDP per capita on the y-axis. So notice points. But as you can tell, now what's new is the fact that we have labels attached to these points. So we can now tell exactly where places like India stand when it comes to democracy and when it comes to GDP. So how do we produce this type of? As before, this is the first layer that's very similar to it's the same as we had initially. So we have the original data frame, EG1. We have the X, we have the Y values, we have Geom Point, and then we have Geom Text with the aesthetic, and when we specifically tell GGplot that the label should be country. And then I am doing this vertical justification, which essentially allows me to place these labels slightly away from the point. I'm actually encouraging you to try different numbers and see how changing the vjust option, how this was going to affect the final look of your graph. Okay, let us now look at Geom Line. So here's an example where this could be relevant. Suppose we have data on average voter turnout in national elections over several years, and we want to see the trend in participation. So let us imagine we have this data frame, EG3, and then we have these 2 variables, year and turnout. So we have these different values for years, so essentially turnout over time, starting with 2000 all the way to 2020. And then we have these numbers, turnout in percent. So this is what timeline could look like. So on the x-axis, we have different years, starting with 2000 all the way to 2020. And on the y-axis, we have turnout. So it's a very straightforward line to show, for example, that turnout increased over time. But what does this look like in terms of code? So we have the data, which is EG3. We have aesthetics, where we have the X, which is year, and we have the Y, which is turnout. And then we have Geom Line. This is an example where we want to use Geom Line. Okay, let us now move to more complex geoms. Remember that we have covered by now points, we have covered lines, we have covered bars and columns. But obviously, GGplot can produce much more advanced, much more complex types of geoms. So once again, this is not a comprehensive list, but I would say these are type of complex geoms that are sometimes used in research. So these could be boxplots, these could be histograms. You could also see density plots. You can see violin plots. Geom Smooth, so these are lines that are fitted within in a data set where you have points, or you can have Geom Errorbar. So when are these used? And obviously, sorry, we also have maps, so something Geom SF. So the question is, when are these used? So the Geom Boxplot, the one here on the left, is something that compares as a type of graph that allows us to compare distributions across groups. A histogram is something that allows us to see the distribution of a single continuous variable. A density plot allows us to see the smoothed distribution of a single continuous variable. Violin plots allows us to look at distributions across categories, so similar in a way to density plots. Geom Smooth is something that allows us to fit a line or smooth a line depending on if we're using a linear model or a lowest function, and so on and so forth. Geom Errorbar is something that allows us to show uncertainty or variability, and Geom SF is complex geom use maps, as you can tell in the figure. So let us examine each one at a time. So let us look at Geom Boxplot. So imagine this situation. Imagine that we examine trust in government, where trust is measured on a 1 to 10 scale, where 1 means no trust and 10 means complete trust. And we would like to compare values and how spread out they are for men and women. So this is our fourth toy data set. We have men and women, and then we have a trust variable. Ignore exactly how we produce this data set for now. So you'd have to first, in order to replicate exactly these results, you simply copy and paste this code in your RStudio version. So you set the seed to 1, 2, 3, and then you create a data frame with these two variables, gender and trust. And then our norm is really a type of function that allows you to create data sets based on a specific distribution. So here we say that we want to create trust values following the normal distribution with 20 values where the mean is 5 and the standard deviation is 2 and 1 respectively. So don't worry too much about how to create a data set. Just create it for now. We want to focus more on how to produce a box plot and how to interpret it. But imagine you have something that looks like this. So you have a variable that's called gender. We have men versus women. And then we have another trust variable that really records people's level of trust in the government. That ranges from 1 to 10. So here's what the final result look like if we look at the entire data set. So rather than looking at how these things differ by gender, at least for the time being, we want to see what the distribution of trust is. So this is a box plot. I'm going to show you the interpretation in a sec. Let us look at how we produce this. So we have the data frame here, which is EG4, and then we have the Y variable, which is the level of trust. We have to then tell GGplot that we want a box plot. So here it is. So this is the final result, but how do we interpret this? This is the interpretation. So this thick line here represents the median value for trust. Ends of the box plot represent the 25th and the 75th percentile. The distance between the upper level of the box and the lower level of the box is called the interquartile range. And then we also have an indication for where the minimum and the maximum values are in our data set. So this is the interpretation of a box plot. As you can see, it tells you a lot of things, which is why many researchers prefer to utilize box plot. But obviously, it's much more helpful if we look at categories. That single box plot showed you what trust looks like in the entire data set. But we would like to analyze what trust looks like for men versus women. So remember that this is what our data set looks like. So once again, we have two variables in our data set, gender and trust. This is how we produce a box plot that allows us to see what the distribution of trust looks like for men versus women. So this is the interpretation. Once again, the thick line here represents the median. So you have the median here. In a fashion similar to before, the ends of the boxes represent the percentiles, and then you have the minimum and the maximum value that's really 75% plus 1.5 times the interquartile range, which is the distance from the top line of the box and the lower level of the box. So this is, I would say, when box plots are really helpful because you want to see the distribution of values per category. Okay, this takes us to the second important complex geom in ggplot, which is histogram, geom histogram. So histograms allow us to better understand how frequently and how infrequently values occur in our data set. So this is here on the right what a histogram looks like. So imagine that first of all, we have a set of values that are spaced out along a number line, as you can see in this moving graph. To construct a histogram, we have to divide all these numbers into tiny chunks. These are called bits. So as you can see in this animation, all these dots that are initially on a single line are added up in different categories. So we're interested in how many observations we have from threshold 1 to threshold 5 to threshold 10, and so on and so forth. So you can see this procedure represented in this animated graph. And then we can draw bars that represent how many points we have in these different bins. So the heights of the bars really correspond to the number of data points per bin. So in this example, the animated example, I'm looking at SAT scores. So the final step in drawing a histogram is really labeling these bins. So the y-axis in the end represents how many data points are there in each bin. So let us look at our concrete example. So let us imagine once again that we have a survey with respondents that measure their level of trust in the government from 1 to 10, where 1 represents low trust versus 10 represents complete trust. So we want to compare values for men and women. In this case, just for the sake of the histogram, we're just going to put everything together. So this is what our histogram looks like. So on the x-axis, we have those values, how much trust do people have? And on the y-axis, we have how many different observations we have for all these different categories. So just to quickly see how we produce this. So we have the data set, which is EG5. We have X, which is the level of trust. Then we have the Geom histogram with 10 bins. I'm going to explain what that means in a few slides. I'm using color equals white because I want to see more effectively the differences between these columns. And then chord Cartesian. This is something that allows us to label the x-axis. So in our case, we start from 2 and we end with 8. So this is, for example, how we produce this graph that shows us the distribution trust within our data set. Okay. As you might imagine, there is a very close connection between histograms and box plots. Here it is. So we have our data set represented as a histogram, and we have our data set represented as a box plot, obviously reversed. So here is the median, both in a histogram and a box plot format. So both of these things show you, in a way, the distribution of our variables. So there is a very close connection between histograms and boxplot. So one specific thing about histograms or utilizing Geom Hist or Geom Histogram is the number of bins. So if we have 2 wide bins, this is going to hide the structure in our data. If the bins are too small, then we're going to get a lot of noise. So here's, for example, how our data or what histograms for our data would change if we use different number of bins. So the first panel here is our data with only 5 bins. The middle graph here shows what our data looks like when we use 10 bins. And then this is what our data looks like if we use 20 bins. So notice how we have fewer and fewer observations as we have more bins, and that makes total sense because this means that the values will be distributed across different bins. Okay, this takes us to another important complex, Geom Density. So this is also connected to a histogram in a way. This is what we did previously. This is, for example, how a density curve smooth buckets. So the buckets relevant for histograms into a single curve that allows us to see the shape of our data. So notice, for example, how this density curve aligns in a way with the columns. So it's important to note that the area under the curve is equal to 1. So this represents 100% of people in our data. If we select specific sections, we can say, for example, that this area here is the probability that a randomly chosen person's score is between certain value. In this particular case, the probability that a randomly chosen person's level of trust is between 5 and 7. This is, for example, what is the probability that a randomly chosen person has a trust score above 5. And then this is the probability that a randomly chosen person has a trust score less than 4. So this would be 12% in this case. So once again, the density function allows us to see a smoothed, it's fundamentally a smoothed histogram. And here too, there is indeed a connection between density and box plots, as you can see on the right-hand side. Okay, so let us now display further how to interpret this geom density. So once again, we're using the same data set on trust. This is, for example, how we produce a density plot. So here we have to make some adjustments in order to get the density to match to the count, to how many observations we have. So we have to produce this. So first we count the number of observations in EG5, which is our main data set. And then this is something that allows us to adjust where that density is in order to display it alongside the histogram. So this is how we draw the density. So once again, we have the data set, which is EG5. We have X, which is the level of trust, and then Geom density. Here too, we're using this additional option. So after stat density multiplied by n and multiplied by bin width. And then we also choose the line width equals 1. So finally, we label our X and Y in order to produce something that looks like this. Obviously, it's actually much more informative if we include the density alongside the histogram, like here, right? So this gives us a better sense, on the one hand, how many different values we have for the different bins, but also more or less the shape of the distribution of our data. So how do we interpret this? Most people in the survey typically gave middle of the road trust scores. So this would be something between 5 and 7. As you can see, as you move towards the extreme, either very low levels of trust or very high levels of trust, the curve drops. So this means that fewer people chose those trust scores. Okay, this takes us to Geom Violin, another type of complex geoms that looks like this. But as you see, Geom density, Geom Violin is essentially Geom density. So here's why. This was our density that we just explained. This is the same density shaded in white. This is the same density flipped. This is the same density mirrored. And finally, this is Geom Violin. So to create this, we simply use the original data frame, which is EG5. We just decide not to label the X because has no meaning. And then we use the Y as trust. And then finally we use Geom Violin. And the output looks like this. Yeah. Okay, but it's even more helpful. So the Geom Violins are even more helpful, similar to box plots, when we are looking at different categories in our data set. Remember that we have trust in government and we have scores for men and women. So for example, this is what the distribution looks like for men, and this is what the distribution looks like for women. So the interpretation here is that men's responses are more spread out from low to high trust, whereas women's responses are much more concentrated into the mid to high range count, meaning women tend to trust government more, and it seems like on average, many women do so, whereas men are more spread out. So there's a few men who trust the government, but there's also quite a few people who don't trust the government. Okay, so how do we use Geom Smooth? So Geom Smooth is a new type of complex geoms that allows us to spell out patterns in our data even more effectively. So remember our EG1 dataset where we're looking at the connection between democracy and GDP. So remember that we have one variable, democracy, and another one, GDP, and then a third one, which is country. So this is once again what our data looks like, 3 variables, and then this is what we had previously. So we have our data set, which is EG1, we have X, which is democracy, and we have Y, which is GDP. Okay, this is what Geom Smooth does. Geom Smooth allows us to fit a line in our data. So this is obviously using a linear model and without standard errors. So this Geom Smooth allows us to fit a line between our points. Once again, this solidifies the idea that there is indeed a positive connection between the level of democracy and GDP. I'm adding the interpretation here. As one moves right, more democratic, the dots usually sit at higher, so countries tend to be richer. And then the line really simplifies or summarizes this intuition. Okay, Geom Errorbars, another type of complex geom. So error bars are like antennae on top of a mean. So they don't really show you the full distribution of the data in the way a box plot would do, but they also do give us a sense of how precise the average is. So you could have situations where you have short bars. So this means that the data points are much closer together, or you can have long bars. So data points are much more spread out. So these could be useful when we want to compare averages. So here's, for example, you may ask what the difference is between Geom Boxplots and Geom Errorbars. So a boxplot shows the distribution of the data, including things like median, quartiles, and potential outliers. And this is, again, helpful to see what the data shape is like. Error bars, on the other hand, they summarize the mean plus some uncertainty, and they don't give us a sense of the full shape of the data. So just to give you a sense of how to produce error bars, once again, remember that this is what our EG looks like. We have gender, we have trust. So this is what our data looks like. And then the first step, or step 2 in this context, in order to create a Geom error bar, we first have to group by gender. So we have to get the mean trust by gender, and then we have to calculate a standard error. So we're using here a standard formula for calculating the standard error, which is the standard deviation of the variable divided by the square root of how many observations we have. And then we also create 95% confidence interval by doing something like this. Mean minus 1.96 multiplied by the standard error. So this is the t-stat corresponding to the 95% confidence level. We do the same for Y max. So just to quickly get a sense of what this data looks like, we have gender, so men and women, and then we have a mean for men, a mean for women, and we also have a standard error for men and a standard error for women. Okay, final step number 3, has to do with producing the graph itself. Similar to before, we're utilizing the name of the data frame. We define what the X and what the Y is. Then we're using Geom Point, which would allow us to create these points. And then the error bar that necessitates a Y min value and a Y max value. This width parameter is something that controls the width of the antennae. Finally, we want to make sure that our X is not labeled, so we simply want to use the genders. Y is trust, and then I also added a title, as you can see here, error bars. And then as a final touch, I also limited how far up and how far down the y-axis goes. In this case, it goes from 0 to 10. Here's that option. Okay, so this is how we produced our error bar plot. Interpretation here: women in the sample show higher levels of trust in government than men. The bars also show some uncertainty since they don't overlap much. So this means that there is potentially a very substantial difference between men and women. Okay, the final geom that we discuss, the final complex geom, is Geom SF. So Geom SF is a powerful geom as it allows us to create maps. It also works with points and with lines. So this is, for example, how Geom SF could be used with points, how Geom SF could be used with lines. So obviously when we're mapping, we could be mapping lines such as roads, we can map rivers. We can also map polygons such as countries. This is, for example, a map of Germany using Geom SF. So fundamentally, there is a specific workflow in order to work with Geom SF. First, you have to get an external shape, countries, regions, rivers, and then you can plot them using Geom SF. So let me show you a specific type of use for Geom SF. So first of all, make sure that you install these packages unless they're already installed on your machine. You load ggplot, you load SF library, you load R natural data and R natural earth. You extract data. So what I'm doing here, I'm extracting median vector data, and then I'm investigating what our data looks like. So this is a very generic type of geographic data set that allows you to map the world. So in this context, in this data set, we have 169 variables that covers 242 observations. It's important to note that in addition to all the countries in the world, there's also some calculations that the authors of the data set did, including what is the average level of economic development for the global south or for OECD countries, which is why we have 242 observations. So this is how we draw a map. First of all, we call ggplot. Second, we call the Geom SF. So in this case, it's the world. And then we just label our map. This is the world SF polygons. We can also, so one good use for Geom SF and frequently used is the use of limits. So chord SF, xlim, and xy. So you can obviously add multiple SF objects, including polygons, points. So this is, for example, how we can limit the extent of our map, essentially focus and zoom in to different countries in Europe. So first of all, I'm defining what my limits for Europe are. So this is what this list does. Europe bounds, you have -1040, and then you have the y-axis 3570. So as before, we have the Geom SF data equals world. Then we tell the program that we want specific extent for our map. And then we also want to add a title to our graph. So this is how these numbers reflect into the extent of the map. So we have -1070, which is here on the left corner. We have 4070, which is on the right corner. Here it is. And then we have -1035, which is on the lower left corner. And then finally 4036, which is on the 4035, which is on the right corner. Let's imagine that we want to add 3 cities. Let's imagine we want to add Rome, Berlin, and Paris. These are their coordinates. So we need a latitude and longitude in order to map them, put them on the map. This is how we convert them to points. So st underscore s underscore sf, which allows us to turn our points into SF points, and then mapping them together. So at the very beginning, ggplot, then we plot the world. So we plot the country shapefiles. Then we plot the cities that we just converted. And then we limit the extent of our map. So we want, let's say, focus on Europe. Here's also an example of how we can map lines. So let's imagine we want to connect Paris, Berlin, and Rome. So the way we do this, we have this st underscore sfc. We turn the cities into a string, and then we provide a CRS. So this is going to allow us, something like this, allow us to produce a graph that looks like this. So just to look at the code once again, we have ggplot. We have the first layer, which is the world. We have cities, which are Berlin, Rome, Paris. We have the line SF, which are these three lines that connect the cities. And then we have the extent of our bound. So we want to focus once again on Europe. Okay, so just to quickly conclude what we covered. So we looked at the grammar of graphics in ggplot. We looked at data, aesthetics, and geoms. Together, they produce visualizations. We made the distinction between simple and complex geoms. Simple geoms include points, bars, lines, and text. Complex geoms are things like histograms, density plots, box plots, violins, and maps that help us further reveal patterns in our data. So maybe one important takeaway is that it's always important to tidy up your data before starting visualizing. Good visualizations entail good clarity and accuracy. Thank you, and see you in the next video. I hope you enjoyed this video. If you found it useful, please don't forget to subscribe, give this video a thumbs up, and please comment down below if there's something in particular in relation to R or to ggplot that you'd like me to make a video about. Thank you, and see you soon.